Hey everyone, it's Timbot here at the TTL Makerspace, back with Freecad for Lasers Part 2. In the first lesson, we modeled a very simple part, and we introduced a concept called parametric modeling as well as aliases. This combination is going to allow us to change the width and the thickness of our tabs and let the software do the hard work of recomputing the model. Now in this next lesson, we're going to get into modeling the slots that correspond with those tabs. But to do it, we're going to have to learn a technique called multibody modeling. Now, we're going to learn the importance of this technique, and to do it, we're going to jump right into the software and learn how to set up a project properly. In this first step, we're going to take a look at this principle. Then we're going to double back and resume work on our project. Let's get into it. And it's a good time for us to talk about why we need multiple bodies for creating parts. In a nutshell, the reason we need multiple bodies inside of a model is because we want to be able to take those parts and move them around in space. So for example, if I grab one of these sides here, I can right click the body and I can go to transform. And I'm allowed to move this around in space. I can pull it, I can take it off to the side here and so forth. I can leave it right over here and that's fine. Whereas inside of a single body, which is made up of sketches or features, those sketches all have to be connected. So let's do a little example here. I'm going to bounce over into the lesson file that we made last week. And let's say, for example, that I want to put, I'm going to put a circuit board inside this enclosure that I'm making. So I want to put little pegs in here for the standoffs that the circuit board's going to sit on top of. Should be pretty straightforward, right? So to do it, there's a couple ways that we can go here. So I'm going to highlight the body that I want to work with. I'm in the part design workbench here. And let's say I go in and I edit the sketch. So I'm going to go into my sketch, jump into edit mode here. I'm going to select a circle, just drop down a little circle here. And I know exactly how far this circle needs to be from this corner. Well, if you remember from our lesson last week, we could use a dimensional constraint. So I'll select the corner, I'll select the center point of my circle, and I'll give it a 4mm distance right there. And then I'm going to do a very similar thing for the vertical distance. Make it 4mm. There we go. And we need one more thing to have this fully constrained, which is to set the size of the circle, actually. We can do that with the radius tool. So I'll say this is maybe like a 2mm radius. There we go. Everything turns green, so we know our sketch is fully constrained. And just like the last lesson, we're going to close that out. But look what happens. Instead of getting a post, I get a hole. And that hole is, right through. It's punched through the padding of the feature. Not exactly what I'm looking for. So there's a couple of ways that we can fix this. First off, let's go back into the sketch. And we're just going to get rid of this circle here, because that is not what we want. But it's useful because it's going to illustrate how we can have multiple sketches inside of a single body. So let's close that out. And this time we're going to do things slightly differently here. We're going to put another sketch right on top of this face here. All right. So we're going to have multiple sketches inside of the same body. And that's going to let us show the use of a tool called the external geometry tool that you're going to use all the time when you're working inside of a body. So I'm going to highlight this face, and from within the part design workbench, I can simply click on create a new sketch. It's automatically going to make the new sketch and put me into edit mode. Now I can still see the part that was defined by my previous sketch. And that's useful, right? Because we want to put a circle relative to this corner here and turn it into a peg, a little standoff for a circuit board. But you see the problem. As I'm hovering on here, I'm not able to highlight any of this geometry. And that is because I am working in a completely separate sketch, and it doesn't know from within this sketch the information from the old sketch, the one I created previously. But there's a way that we can say, okay, let me look at the other sketch and find the values of, say, this corner right here. That's extremely useful. So it's time to take a look at the external geometry tool. And I'm going to find it, going to find it right in here. Looks like a little blue box right here. And so I'm going to click on that one. And what it allows me to do now, as I'm moving over that external geometry, you can see that I'm able to highlight things. And if I click on this little corner here, this is creating a reference to the information from the other sketch. I'll exit out of this tool and let's see how we can make use of that. You can probably guess already that we're going to use this as an anchor point for creating our standoff peg. So just like before, I'm able to go in, grab my little circle tool, just like that. Then we're going to highlight that external reference, and we can use it just like as if it was in the same sketch. So let's make this 4 millimeters over just to illustrate things. 4 millimeters vertical constraint. There we go. And do you remember the other thing that we need to do? Yeah, that's right. Got to set the radius. So I'll make this a 2 millimeter radius. You know, we're just messing around. I'm not planning to put a circuit board in this project. But you can see how we're now fully constrained, right? That's pretty useful. If we close it out, you're going to see that it's highlighted in green here. And we can use our usual tools so we can actually pad that circle out, right? And there we go. We would have our little, peg to be the standoff. And so the important thing to notice here is that in our model, the reason this works is because we're within the same body, right? So this sketch here, sketch 001, can reference the geometry of another sketch that's inside the same body, but it cannot reference a sketch that is inside of a separate body.
Okay, now Freecad will make a lot more sense if you can remember this simple rule. The external geometry tool can only reference sketches in the same body that you're working in. And all the features inside of that body need to be connected. You can't have another piece floating off in space.
Well, let me show you what I mean. So I'm going to close up this body. I'm going to highlight on the part itself. And let's just create another little part here just by making a real simple sketch. We're going to create a new body right here. And then within the body, we're going to make a new sketch. And maybe this time, let's just put it on this plane right here. And that's going to also help us out when we're creating the sides that we need. But we're just kind of illustrating a few important concepts about CAD modeling in general and Freecad in particular. So I'm going to say OK. And now I'm looking at the side of this part. And let me throw a little shape up in here. We'll just do like a real simple square. Something like this. There we go. I'm not even going to constrain it because that's not what I'm concerned about right now. Let me close out this sketch. And you can see that it's, kind of intersecting the middle because we put it on the center axis of our world here. But we can still pad it out. So let's pad it out to like maybe like a 3 mm. There we go. And now if we look in the model, you can see that we've got two bodies, right? So we can rename these, and we probably should, because this can start getting a little complicated. So let's rename this body, and we're going to call it bottom. And we'll also rename this body, and we'll call it side. There we go. All right. Now, with that side, it does not have to be connected to this part the way that we see here. The reason why is because it is a separate body. And we can actually right-click this, and we can go to transform in order to move it over to like roughly where we want it to be, right? We'll say okay. Now the thing is, if I want to model inside of this body, but reference information from this other body, the sketches inside of this body, or even the faces created by the padding, I will not be able to do it using that external geometry tool. Let's test that. I'm going to go into edit mode on this sketch again. I'm going to bring up my external geometry tool. And now, as I move around on the other body, you can see I'm not getting any highlights, right? I cannot reference any of that. In fact, I think I'll get an error message if I try to. Yeah, see a little no can do symbol there.
So have you got the idea? Having multiple bodies allows us to move a bunch of features using a transform. But if we want to reference geometry from one body inside of another body, well, we're going to have to use a tool that's called the Subshape Binder. Now we're going to be using that to perfectly position the slots in one body using the tabs in our first body.
Okay, I've gone in and I have cleaned up the garbage that I created in my part while we were just looking at options. And so the important part of the lesson now is that we're going to learn to work with this tool called the Subshape Binder. And we're going to do it by creating the sides for our project here. And we're going to create perfect slots for these that correspond with these tabs that we've created here. All right, so let's get started. And the important thing is that I want to make sure that I start off by creating a new part, a new body, because I want to be able to move this body around in space. So let's highlight on our part. We are in the part design workbench, and we're going to create a new body. And then we're immediately going to create a sketch inside of that body. So let's go ahead and do it. And I want my sides to be perpendicular to the bottom that we've created here. So I'm going to select the YZ plane in this case. We'll hit OK. We're immediately going to go into sketch mode, and we can start modeling out our side here. So why don't I do it very simply at first, just with a little square shape. Later on, we'll be able to go back and get a little bit fancier if we want. And I'll just pick out something like that. Now I do think I want to get this sketch constrained. So to do it, let's put a few dimensions in here. So I'm going to select this top line. We'll give it a horizontal constraint. 100 sounds good. Going to give ourselves a vertical dimensional constraint. We'll call this 50, so it's like 100 by 50, pretty straightforward. And then in order, like I won't really be able to necessarily use symmetry against the middle for this one, as we've done previously, simply because they aren't symmetrical. This corner and this corner I intend to keep different distances from the center point here. So I think in this case, we'll just do it up very simply by using a dimensional constraint. So I'm going to say between this point and this point, horizontally, it needs to be 50 millimeters, half of my width. And then I need a similar thing vertically. There we go. And so this is going to be, let's make it like 9. There we go. So now we're fully constrained and we're ready to close out the sketch and move on to the primary part of this lesson, which is working with the shape binder to create the slots for our tabs. So let's go ahead and close this one out. And we're moving a little bit faster now because these are things we've done a few times. You could probably guess what I want to do next. I'm going to give it a little bit of thickness by just padding this out. So I'm going to hit the pad. And what I want to do here is not hard code this. Instead, we're going to go to our spreadsheet. And we're going to look for the material thickness. There we go. And that's going to give us our 5 millimeter. Make sure that we stay parametric. I'm going to hit the OK. And if we go back to the model, now because we have created a new body, we can right click this and we can transform it. We're allowed to move it around in space. There we go. So I'm going to bring this up until just just a little bit of those tabs are showing through.
All right, we're now perfectly set up to create the sides of our model. And this is the most important part of this lesson. We're going to be using the Subshape Binder to line up the slots in our new sides with the part that we made in the last lesson.
We noticed in the previous section that we can't use the external geometry tool between two bodies. It just won't work. So instead, what we need to do is create a reference inside of this body to the geometry of this body. And that's a perfect use of this little green blob we see up here called the Subshape Binder. To make this work, we have to make sure that we have an active body. So right here, I'm going to rename this to side so I don't confuse myself. There we go. And the way that I know that the side is the currently active body is that it's bolded here inside the model hierarchy. I can change that if I double click the bottom, that now becomes the active one. So just make sure that the body that you want to create the Subshape Binder in is the active one. So let's double click the side again. There we go. Okay, so now we're ready to create that reference to the bottom body. And to do it, I'm basically going to just click on one of the faces, and then I can hold down Control and click More Faces for any of the references that I want to create inside of the Subshape Binder. And so now you can feel free to just go ahead and click right on that sub-object shape binder. Bam, just like that. And what you're looking for is that the binder would be created in the active body. Okay, you don't want the binder created in the bottom here. You want it created in the side. Now that we have that, I'm going to get you to do one more thing we haven't done before. You're going to click on the bottom, not double click. You're just going to click one time, and you can go ahead and hit spacebar, which will hide that. That's going to be important for us to use our external geometry tool and to be able to work inside of the side here.
Now, since these tabs are parametric and they use aliases, if we change the width, the height, or even the position of them, they'll automatically update inside the slots. But to do it, we need to use the Subshape Binder. So let's go ahead and set that up.
Okay, so now expand until you can see the sketch that's defining our side here. We're going to go into edit mode by double clicking it. Okay, now you can clearly see that these geometries are visible here. But you cannot just click on the points, right? You have to use that external geometry tool that we used in the last lesson. So I'm going to bring it up right here. And now, as I move over this information created by the Subshape Binder, you can see I've got a point right here that I can highlight. I've got a point I can highlight right here. Highlight this point. Highlight this point. And now I have all the geometry that I need to create perfect slots inside of this side piece. We'll escape. There you go. And we're just going to take our little square tool and we're going to start drawing onto that geometry. There we go. Now you can see that it has automatically constrained these corners here with a coincident constraint. It basically is guessing that we want to keep these 2 points exactly on top of each other, and it's filling it in for us. Now you'll notice that we're already fully constrained. See, we have nothing unsolved in the solver messages here. And the reason why is because the shape binder that we created was created on top of geometry that was fully constrained. In other words, our bottom point, because it's fully constrained, anything that we bind to it also becomes fully constrained. So you can see that it gets very important to constrain your sketches wherever possible, because down the road, you can start running into a lot of problems if they aren't. Let's put our second slot on here. Boom. Just like that. Boom. Just like that. We'll escape out of that tool. And that is pretty much all we need to do, actually, in order to create these perfect slots. If we close the sketch, you can see that the slots are perfectly cut. We can click on the model and we can bring back the bottom by highlighting it and hitting the space bar. Now you'll notice that the active body is still the side because we didn't double click the bottom. We just click it one time. All right, and that looks pretty darn good. Now what about the other side? Well, the other side is going to be ridiculously easy for us to do. We'll highlight on that side, and you'll notice there's a little sheep up here. That's the clone tool. And if you click that, it's going to make an exact copy of this first side that we've created. Go ahead and click it. We're going to rename it right away. I'll call it side 2. There we go. And now, because it's its own body, we can right click it, go to transform, and we can actually pull it over to the other side. Nice. And its slots will also work perfectly. That looks pretty good to me. Now, let's test the parametric ability of this thing. So let's go back to our model. We're going to open up the spreadsheet. And let's change our material thickness here. Let's switch it to, say, 2 millimeter. Let's see how well we did. Bingo. Perfect. Now, the only thing you'll notice here, although the parts are perfect and have reformed, they're no longer aligned here, right? Because of the lower thickness, we've got a little gap in between these two parts right here. Now, we may or may not care about that. It's easy enough for me to grab that piece, hit the transform, and just snug it up here. But I almost don't care about that. Like, we could fix that, but at the end of the day, we're taking all of these parts, we're gonna lay them out flat and create flat vectors out of them that we can send to the laser for cutting. So it's not that big of an issue to me if I get little gaps like that. What I do care about is, like, do these slots and tabs fit perfectly? Which right now, it certainly appears like they do.
We're getting really close now to being able to actually produce these parts on the laser. But to do it, we're going to have to learn one more facet of multi-body modeling, which is how to take our three-dimensional parts and transform them into 2D shapes that are appropriate for the laser. So let's jump back into Freecad for a quick review of what we've achieved so far.
And we've essentially learned all of the tools that we need to make perfect slots and tabs. And by following this method, we can basically build up any kind of enclosure that we want. We can make it very decorative, and that's pretty exciting. In the future lesson, what we're going to learn is the final step, which is how we take these parts, lay them out flat, and turn them into a format that's suitable for the laser cutter. After that, we'll be able to bring it over into a software like Lightburn, send it into the laser, and see how we do with our actual produced part. I am greatly looking forward to that, so hopefully you are enjoying these lessons, and look forward to the next one.
In our next video, we're going to learn to use the draft workbench in Freecad to prep our parts in 2D for output to the laser. You're going to want to not miss that one.